Sahel, thank you very much indeed to you for your insights into BIM, and hopefully that's been insightful for one and all this afternoon. We're going to have one more session, then we break for lunch. We're going to turn our attention, we'll continue the conversation with regards to BIM. We're going to turn our attention now to transportation. This next session is called Driving Simulation for Transportation. It's going to allow you to understand the advantages of driving simulation for highway projects, the use of 3ds Max to optimize Infraworks road models, setting up an open driving simulator project using a driving simulator to review highway projects and more. Now, the person to take us there is an individual with over 15 years experience in construction, during which he worked on challenging global projects. He believes that effective communication means all players understand and can contribute to the design at the right time. Immersive technology, if you like, provides the interface. It connects people with digital models in construction projects. He helped his company, AECOM Middle East, to develop immersive content for regional projects using a variety of technologies, which will be highlighted for us during this presentation. Virtualization, augmentation, virtual reality, just a few of those. Deployment of platforms include VR headsets, smart devices, touchscreens, web and projection with head tracking for holographic interaction. I'm going to allow him to tell you a lot more about this during the next session or so. If there are any questions that crop up during the session, please, please, please do direct them to the social media platforms using the hashtag throughout proceedings. But without further ado, ladies and gentlemen, join me in welcoming up onto stage for driving simulation for transportation projects. It is Charles Dunk. Please welcome Charles Dunk, Civil BIM Manager.
Hello everyone. Thanks to Autodesk for inviting me today to talk about driving simulation for transportation projects. We've got a journey today, if you excuse the pun. We've got about, I'm going to talk for about 50 minutes on driving simulation. We're going to go through the why. We'll talk about why we would need driving simulation, what's the purpose of even doing it. Second section, we'll look at the what is out there, what's the options for you with driving simulation. And then finally, we'll go on to the how. We'll dive down into the nitty-gritty, the Autodesk solution for driving simulation on transportation projects. I've got 15 years, as mentioned, 50 years experience in civil engineering across the world, in the UK, New Zealand. I've worked on the contractor side and the consultant side. I've been in the region about 8 years. So I think I've got some experience there that allows me to understand a bit of the risks involved at the pre-construction planning stages, the concept stages through to the construction stage and the operation side. And so driving simulation is a way of looking at this risk and managing it and making the projects move forward. How do we currently visualize projects? We use renderings. We use, increasingly, we've got software like Infraworks. We'll use nice rendered videos, maybe, and reports, drawings. But not everybody can understand these, particularly when we're engaging stakeholders, when we're engaging utility companies and the general public. There is a natural way to interact with the digital content, and we're going to explore that today. So what is natural interaction? Natural interaction is intuitively understanding your environment, your digital environment. And we're probably familiar with virtual reality. We've seen there's been a lot of publicity around virtual reality. But virtual reality is not necessarily the right solution in this context. It's partway there, but how do we explore transportation projects? Typically in a vehicle of some description, or we will walk around, or we'll cycle around, or we'll move around our environment at ground level. A lot of these visualizations that we see out there, we use these software like Navisworks or Infraworks, and would have almost like a helicopter view over the project. Virtual reality isn't for everybody. I don't know how many in the audience have tried it. I think there's a threshold, there's a tolerance for how comfortable. Some people will put the headset on and they can't deal with it at all. I find from use of virtual reality with clients and colleagues, that is about half of people, maybe a bit less, find it uncomfortable. I think that's going to improve as the technology, we're still on the first generation of headsets. But so, VR is good and it's improving and it's a good way of interacting, but we need to find another way or a more intuitive way of exploring our designs in transportation. After talking with software vendors this year, not only Autodesk, we're seeing convergence of the capabilities of our computing power with our collaborators in the project. And what I mean, that didn't come out well, is now the software being used by engineers, architects to design their projects is now capable of actually driving good-looking and realistic visualizations within that software itself. This is called real-time design. So we're not limited now to actually sending off our content to a visualizer, to a 3D designer. We can actually see what it's like actually at the coalface, the guys doing the work. Continuing with the why, we're still in the why stage. So getting approval is a big challenge at the early stage and in any region for large transportation infrastructure projects. We have many stakeholders, landowners, we have utility companies, we'll have statutory authorities, the general public that we have to engage and to get projects moving forward. And it's a major risk for the collaborators, particularly pre-construction, to get these projects moving forward and get them going to the tender stage. So I wanted to demonstrate, pull back the curtain a little bit, what we're doing in AECOM with driving simulation. Now this looks a little bit funny on the screen because what you're seeing, if you can try and imagine, this is actually a completely 360-degree video. If you imagine a piece of paper around your head and then unwrapped, that's what you're seeing on the screen. This is actually the video that was put inside of in this case, a Gear VR headset to demonstrate to our client what it would be like to drive along their new road scheme. We developed this content because the client asked us, hey, we want to understand the project a bit more, we need to engage our engineers, our management. And we were proposing in this project something that's a little bit unusual. We were proposing a road scheme. You're probably familiar with driving around Dubai or in this region actually, where they use the American standard for geometric highway design. There's these cloverleaf junctions where now we were proposing not a cloverleaf junction. So this added risk to the approval process or added extra duration. So we developed this VR experience to demonstrate different parts of the project, and it ran for about 3 minutes, and we put the driver at different parts of the project to demonstrate how they would change lanes, how they would accelerate, what they would see from different parts of the project. So relatively simple, sort of low-level visualization, not the greatest quality of graphics if you're familiar with visualization, but it was reasonably successful. So at the other end of the scale of simulation, this is in the UK. This is a university, Leeds University. They've let us use a couple of £1 million simulator. This isn't a flight simulator, this is a car simulator. And in some ways it's more complicated than a flight simulator because it actually moves on rails to simulate your horizontal and sideways movement. We're using this simulator, we've been engaged by the UK Highways Agency to explore and understand the impact of traffic management on driver behaviour. We're probably all like, well, it basically makes you angry. No, this is to understand how do they react to different types of traffic management, cones, barriers, signs, illuminated signs. How does it affect them during the day, night time? And it's part of the all lanes running that they want to, the UK Highways Agency want to look at how to get the most out of the existing highway infrastructure in the UK. So that really is the either end of the sort of the scale of simulation. So, talking about the hardware and there's a scale. We're now moving into the what stage, what's available out there for the simulation. So the cool stuff, the big stuff. This is awesome, and this is General Motors, where they have a full-scale setup. Hydraulic actuators underneath the vehicle, the dashboard works, and some very high-quality visuals in there. And GM use it internally for their own engineers to understand if they change the interior of a car, how does that affect the driver. They use it for getting highway to get them the safety rating. And they use it for engaging the general public, marketing obviously, and other uses. And this is a top-end setup. So we're just talking about the physical setup for now. We'll go onto the content shortly. I don't want to say right at the other end, but at the other end, towards the other end, shall we say, of the physical setup. This is a commercial off-the-shelf COTS, commercial off-the-shelf type setup. You could go to Visaro's website, pick, I want this type of seat, I want these type of screens, and they'll put it in a box and send it over. This is still very sophisticated technology. At the back, towards the back of the seat, you can see the little pistons. They're actuators. They're actually electric actuators, which will move them around. We're still talking in the region of 250, 300,000 dirhams, so not pocket change, but provides a very realistic and immersive experience, which is what my group in ACOM's all about, immersive technology. Something that's interesting about this particular setup is that if you were lucky enough to be a racing driver and you have your own Porsche GT, you can unclip your steering wheel from your real car and pop it into the steering wheel here to give you that real sort of sense of simulation. And it really relies on very good laser scans of the racetracks. Now, I said virtual reality towards the beginning of the presentation is not the most natural way, but if you couple it in a transportation context with a cockpit, this is a fantastic way of actually combining virtual reality and transportation projects. One of the issues with VR at the moment is presence. And what I mean is being able to see yourself within the digital environment, because remember, your vision is completely obstructed by the VR headset. So when you look down, you either see nothing or you see this digital representation of somebody else. And this helps to, or this can break the feeling of immersion. They're working on it, and I've seen types of scanners that will scan you as you've got the headset on, so you can actually see what you're wearing today and not just generic. What's good about this is that the software knows where you're going to be. It knows where your arms are going, your hands are going to be touching the steering wheel, you know your feet are going to be on the pedals, and if you change gear, your hand's going to be about here. So the software, without actually having to scan you, knows where you're going to be. So you can see, in the digital world, you can see your hands on the steering wheel. You don't move around much, as in physically, although virtually you do. I would just add a note of caution with regards to actuators. A lot of people want to go, oh, let's move the seat around. In a transportation project, that's not always necessary. With car racing and you're banking around these 20% corners, you'll want to experience that movement in the simulator. In transportation context, we won't be going 250 kilometers an hour. I hope we won't be. So these actuators, they can lead to, they are difficult to implement, and they don't necessarily provide a lot more immersion. The virtual reality, coupled with a headset, great way of implementing driving simulation within transportation projects. We don't have to worry about modeling, like physically building the interior of a car. We can simulate Toyota Corolla and Mercedes and all different types of vehicles. So earlier, we showed the Gear VR, and we had the video with the wraparound video. This is what I call, I haven't found anybody else, I call it driving simulation, because actually you're just sitting there with a headset on. There's no other interface. So that was what I would call driving simulation in inverted commas. You're in a car, but you can't control it. And if you noticed in the video, you were sat, or the user was sat in the driver's seat. And I think if I was to run that again, I would actually put the user in the passenger seat, because you can't actually control where the vehicle goes, the acceleration, do anything with the indicators. So that was sort of driving simulation, but as a passenger. It's still a fantastic way of creating driving simulation. We can have very high quality visuals. We can spend a lot of time with the computer at the back end and do these very highly rendered experiences, but it's not interactive. You put the headset on, it runs for 3 minutes, take the headset off, and that's it. You can't explore further. You can look all the way around, great. You know, you can pause, you can hold, you can look over your shoulder, but not interactive. So driving simulation, that level, adding that interactivity is very challenging. You must model the environment digitally. You must have interface with the hardware. You must know what hardware displays you're going to be using. When I rehearsed this with colleagues, they thought that was a photo. But it's not. That's a rendered image from Project Cars. Grand Theft Auto. Does anybody, you've probably heard of Grand Theft Auto 5 and these other games. Grand Theft Auto cost $250 million, cost Rockstar Studio $250 million to make. That was their investment on their side. They model, if you're not familiar with this game, it's for the consoles. It has a very large artificial city where you can drive around. It's fully interactive. You can go explore buildings. You see people walking around, and it's a very highly detailed, data-rich city. Project Cars, which you're seeing on the screen, focuses on the experience of racing around racetracks. So they don't model whole cities, and they don't necessarily have pedestrians walking around, but they focus very heavily on very high quality physics high quality visualizations around racetracks. This sets the bar. This makes it very challenging for companies like us who are in the construction industry and trying to do driving simulation. We can't get that level. We don't have $250 million to invest. The client doesn't have that. Why would they? We only have Rockstar Studios can sell their game 10 million times. We can only sell our driving simulation once. So to try and get that level of realism is extremely difficult, and we need to focus, make sure the simulation is focused on what's on the outcome that's required for the project at the different stages. It's very easy to get focused on the visuals, particularly the virtual reality. Everyone is like, oh my gosh, that looks amazing. But we've got 6 senses. I know there's the movie Six Senses, there's 5, 6. The one that the people are not aware of is called proprioception, which is where all your limbs are in space. But we need to engage all the senses, and one of them is also your motion, which is your inner ear, your vestibular system. But we need to think about the sound, making sure that the sound is the right. I mean, temptation when you get one of these simulators like we saw earlier, put it in your house or in the workplace, crank the volume up because you want to have that experience. But if you're driving a Yaris or a Ford Fiesta, it's not going to be loud. So you need to set the physical setup corresponding to what you're digitally representing. And talking of digitally representing, we need to represent physics. And this isn't the exciting part of simulation, but it's what goes on in the background so that the weight of the car is simulated, so that your acceleration and deceleration and your braking. Your steering, your turning circle is realistic, and that when you turn the steering wheel, you are actually turning the same amount in the software. You need to represent the physics of collision as well, the energy involved in your collisions. Something that's quite challenging, and the computer game designers would understand much more, is about artificial intelligence. And when I say artificial intelligence, I mean of the other digitally computer-controlled vehicles and pedestrians inside your model. They need to react naturally, particularly like in the earlier one where we were looking at acceleration and deceleration areas emerging. We need to have a realistic approach from the computer-controlled vehicles so that it's a genuine simulation and it's not just a game or something that's good looking. So the physics behind it, the artificial intelligence behind it is very important. But having said that, we can still use driving simulation without needing to go for the top end. We can achieve some very good results with using simple visualization and simple physics, particularly around some types of understanding distraction and understanding the spatial relationship on projects like master planning projects, for instance, where we're not looking at exactly driver behavior, we're trying to understand the flow around a new residential housing estate or a new master planning city. So there's still a scope for controlling. We can control the physics, make it simpler to drive. We don't have to worry about exactly the steering wheel. We can have low polygons. This is a great way of also being able to pare it down for mobile devices so that we can engage the general public with a mobile app. If we know that it's low polygon, low physics, it's, I'm going to say easy, but it's easier to implement into mobile devices. Still on the how, we're gonna go towards the We're in the what are the options, and soon we'll be getting into the how we do this. This is a courtesy of Cruden, who make the top end, that sort of simulator that we saw at Leeds University, that sort of scale of simulation. They do the big simulators. A lot of these companies start off in, they do military simulations or flight simulation, and then they realize that there's a market for car simulation. If you were a client or somebody considering simulation, then at the top of the row there is the hardware setup. How much do you want to invest in the hardware? But then you don't want to spend $2 million on an amazing simulator and then not have great content. So the second half at the bottom there is about the content, making sure that the content is suitable, and why are you implementing driving simulation to begin with. There's an interesting look into people's psyche about driving simulation and using simulators generally, and I was quite surprised after talking with colleagues in the UK, but it also is one of those ones when it seemed obvious afterwards as well. You have to be careful with driving simulation in terms of training people. That if you put somebody inside a simulator and say, right, okay, we're going to learn how to do skids, you're going to learn how to manage a skid, they might, there's statistics have shown that actually they are no better afterwards than they were before they used the simulator. In fact, it can lead to overconfidence. Putting people inside simulators can lead to them becoming, having bad driving habits, because there's no consequence. If you, half of the people I stick in our simulator in ACOM, in our office, they go, great, well, I can do all the things that I can't do in the real world, and I drive over the grass, and I drive through red traffic lights, because there's no consequence. And this can reinforce, if you're seriously considering the use of driving simulation for training, this is can actually reinforce bad habits. So we can use simulation for something, as I mentioned, like to say distracted driving, because we're testing the person's ability to cope with multitasking. And actually, they could be on a flight simulator or they could be doing knitting. What you're testing is their ability to, how well they drive around their environment before they're on their mobile phone or tweeting or whatever they do. And then you test them before and afterwards and see how well they do. So you can use driving simulation for things like testing distracted driving. Now, you say, but hold on, airlines use flight simulators all the time. Should I be worried? The reason why flight simulators work in the airline industry is because of the preparation and the consequence that's involved. Obviously, there's the moral consequence of the pilot and his responsibility to the people on his plane. But the consequence in terms of his career and his ability to progress and even actually to be a pilot. So flight simulation works, and I'm sure there's somebody who could talk about this for much longer than I, but it's simply put, it works because there's consequence and because the amount of preparation that they use the driving simulator, use the flight simulator for, they prepare many, many hours before they go into the flight simulator. So it's not a magic bullet, but it is a great way of supporting the culture of improving safety and training for driving. A little plug about ACOM, and then we're gonna dive into the nitty-gritty how to use Autodesk's solutions for driving simulation. I feel really confident with the support that I get at ACOM, because we're a global leader in infrastructure and transportation projects. We have, last count, about 85,000 people in, I think, over 300 offices around the world. We know, or we think we know, transportation and infrastructure. We don't design cars or motorbikes or any type of road vehicle. So we can use simulation ourselves to bring those two together and understand how do different types of vehicles cope with our roads. Now we'll use traffic simulation software like Vism. We will use other software to simulate the flow of traffic, but what's it like for the end user actually moving around the project? That's where driving simulation comes in. We have in the US, it's funny, AECOM's one of those companies that you suddenly find out you've got a whole nother division. It's such a big company. We have a team in the US that works with the Department of Defense, and when you work with federal authorities in the US, you have to actually own the rights to your product that you'll use or you're selling to them. So we actually built from the ground up our own physics engines, our own simulation engines, the interfacing, the hardware interface to work with the simulators that the Department of Defense has. So combined with colleagues in the UK, the support I get from the transportation planners, the highway engineers, guys in the US, I think that we're well placed with simulation, both here and globally. So we're going to get into the how we do it now, and this is the Autodesk event. Now, when I approached this and I was talking with the events, I was looking at a piece of software called the Open Driving Simulator. That is mentioned in the blurb, but it's we're actually going to use another platform, Stingray. You've probably heard of. I'll be happy to field questions about the Open Driving Simulator. I'll briefly mention it, but we're going to dive down into the Autodesk workflow or pipeline for creating driving simulation. But if you're out there and you're deciding, right, okay, this driving simulation, I want to test the water, give it a go, I don't want to spend too much money. This is the different options for you out there. And the first one is what we're going to dive into later, which is game engines. The Autodesk Stingray is the game engine we're using, but if you're familiar with these types of platforms, we've got Unreal and Unity, and there are a few others out there. They're a great tool, but they have quite a long development time. They require a lot of man hours. They need a lot of skill, but you are working from the ground up, so you can build a very bespoke solution. You can control the physics, you can control the visuals, sounds. You can start to add in the hardware interfaces and really manage it yourself. The second option is the existing visualization packages. So I'm talking about software like Navisworks or similar, where we can, and if you're not familiar with Navisworks, it's a great tool. You can just basically pour any type of data into it, Civil 3D, Infraworks. You can drop in all types of content, and you can explore your transportation project in there. Now, it's difficult to actually do driving simulation, if not impossible. There are ways of mapping steering wheels, pedals, joysticks to keystrokes. Not great. It's more this type of software is designed for this helicopter view or creating visualization renders, videos, sorry. But still, a way that you can do it. There's a third-person view typically in software like Navisworks, but you kind of have to press forward, and it's like you're bionic man and you're running 1,000,000 miles an hour. Third type of navigating around infrastructure projects is real-time software. So I'm talking about Infraworks and other tools like that, where we can explore our environment, where the software vendor has provided an interface which is like a driving simulation. But again, you will have to just cope with whatever the vendor has put in there to support the hardware that you're using. The R&D simulation packages, these are software suite that is like manages that big bubble multi-million-dollar simulator that you saw earlier from Leeds University. This is a type of software package that's very unique, and you'll only find it, they only sell 10 licenses a year because they're very unique. They are, in terms of the physics anyway, they're the top end. The top end of the scale. You could simulate the amount of fuel that's in your engine, the type of polymer that you've got inside of your suspension, amount of tire wear that you have, because this is a very, very high-end simulation. We explored it, but the cost is fairly exorbitant unless you're going to be using this for, let's say, car manufacturer. And the last one, which is a great way of dipping your toes, and I'd recommend this to anybody who's starting on the road, is to get an existing driving game. We tested Assetto Corsa, if you're familiar. There are others out there as well. I think Forza and I think Project Cars as well. They have the facility to be able to have custom tracks, custom roads. It's not as straightforward as just copy-paste, going into Infraworks, right, I highlight this area, going to put it in there into the racing simulator. It does require a bit of work, possibly in Max or some other software like that. But you know, if you're using a gaming engine, you know that the physics is going to work. It comes preloaded with a whole bunch of cars. You know that they've already done all the hard work around the hardware interface. If you're going to use different types of steering wheels, it controls all your monitors or projection. So it's a very simple way of starting off on that road in simulation. Now, you can't just go to online and spend $20 and download a copy of Assetto Corsa and think, oh, that's only cost me $20. You actually have to use, their license prohibits that type of use, so you need to make sure that you look closely at the license. You'll be talking about a couple of $1,000s to be able to use it as part of your own projects. If you are making revenue off the back of that, then you have to be careful with the licensing. There's also branding issues as well. Obviously, when you switch it on, it'll be all Assetto Corsa this or Forza that. You can't control the. You want to have your own company or the project branding on there. That's not possible. So we're going to focus on option one, which is the game engine solution. So there are the steps to simulation to be able to create your own simulation content. Is first thing to do is obviously the environment, the modeling, what we're going to drive around. So Infraworks, great tool of choice. I really enjoy using Infraworks. Infraworks is a really good tool for developing that model. If you're thinking about multiple iterations, you can use the proposals options in Infraworks. You need to model existing conditions. Typically, transportation projects have some kind of existing conditions that they interface with. We're not building a road on Mars. We're actually building a road somewhere where there are going to be some other roads or highways or built environment that we need to model. So we can use tools like Infraworks, which understands GIS, understands laser scan data, traditional survey data, a bit like Navisworks. It has a similar like data import option that you can just pour about pretty much any data and more into it. It's a great tool for developing your model that you're going to be, or your environment, sorry, for driving around. But it's still at the early stages, so that model is not necessarily going to be able to just drop it in. I wish that was so, and I think talking with Autodesk and that they're going to be supporting this in a similar way to Autodesk Live. If you've heard of Autodesk Live, that's a great way of turning Revit models into these virtual reality environment. It's almost one click and it's done, and you can stick on a headset. that's the intention, or it's one of the ideas in their pipeline. But currently, we have to clean up the model, and by that I mean for the technical people out there, we have to make sure the normals are facing in the right direction. We have to fix textures. I'll go on to a little bit about that later. The next stage is content gathering, and what I mean is the other assets. So we've designed, typically highway engineers, planners will think about, well, okay, the buildings and the roads, and but we need to have realistic vegetation, we need to have all the sort of content that you get if you're a computer game designer. So you need to have the other vehicles relevant to your area, you need to have, if you've got pedestrians, you need to get culturally sensitive pedestrians. Do you model those yourself? Do you buy them? Where do you get that content from? Because driving around a ghost town isn't really very realistic. So the next stage is to gather the content. After that, we've got, this is where we're moving into the gaming environment, like Stingray. So we'll take our rationalized, our fixed assets that we've sorted out, and we'll start to build our own little sort of SimCity environment. We might use paths that come from Max, or we might start to populate and put in roads from using Stingray itself. We'll start to put in pedestrians, we'll start to maybe put in, if we're modeling Dubai, we'd start to put relevant buildings in. We could use low polygon, low texture like we see, sorry, on the next slide. Or we can use these highly rendered, highly detailed models of buildings within Dubai. Testing, so that's testing by the developers themselves, by Immersive Technology Group. We would test it just to make sure it actually runs stably. But then there needs to be a testing on the target hardware, and if it is going to be going, so we need to make sure it runs on the hardware correctly. If it's going to be on the mobile devices as well. And then finally deploy, and in fact, I probably should have put a feedback loop, because from deploy, we're looking for feedback, and not only feedback on the transportation project that we've modeled, obviously that's pretty much the primary reason why we've developed this model is for exploring the environment. But we as the Immersive Technology Group, we need to have feedback on how did it run? Did the software run okay? Was it stable? What was the experience like? Could you drive through something that you're not meant to, and vice versa? So that in a nutshell is the Autodesk workflow as it stands for driving simulation, starting off with Infraworks. So now I'm going to dive down in those 5 or 6 stages. We're going to look in a little bit more detail for each of those bubbles. So rationalizing the environment, if we were to use an Infraworks model directly in Stingray, it wouldn't run, or it might run but very badly. So we have to take the Infraworks model, and we can do some work inside Infraworks before we even get to Stingray, and we'll probably do something halfway in between Stingray and Infraworks, typically with Max, but there are other options. We need to make sure something that is we need to be careful of is the vegetation, particularly trees and planting, because they've high polygon counts, and it's all about the polygons, particularly when we're dealing with the lower spec machines that we're deploying to. So we need to, inside Infraworks, just be a little bit more, maybe create a scenario inside Infraworks. If you're familiar with Infraworks, you can sort of roll it forward and backwards into different scenarios. Create a scenario inside Infraworks that we know is going to be exported and created as part of the driving simulation. What's good about, there's many things good about Infraworks, but we start to get the junctions are all built automatically for us with all the lining on there. Don't have to worry about that so much. And when we rationalize the environment, we can use this. We need to reduce the meshes, and this is a fairly complicated process, sometimes called decimation. It's a way of, and again, computer game designers will be very familiar with this, it's a way of being able to, what looks like a very highly detailed model of a BMW M3, in fact actually only has a very few number of polygons. And the process of reducing the mesh, or the amount of triangles that represent the shape of that car, is called decimation. And if you're not a big 3ds Max user, which if you, my background is more in the Infraworks civil 3D side, and then at the other end of the scale at the Open Driving Simulator or Stingray and the gaming engine, that bit in the middle, I have to rely on my colleagues to help me out with that sort of fixture, fixing particularly the meshes and the textures. There's some other tools out there if you don't want to go down the Max route. There is, and Autodesk products as well, Mesh Mixer and Remake and Recap, and a few others out there which you don't have to worry about the whole interface of Max, and does that work for you. You have to be careful with the textures, understand a little bit about that, and there's also Mesh Labs, open platform which you can use for fixing textures. If we choose objects in Infraworks, and this comes down to a bit of trial and error, if we choose the right objects in Infraworks, they come there. You make your life a lot better, a lot easier later on. So, when Infraworks has been around now for, I don't know, about 4 years in its current state, maybe a bit longer. I'll probably be corrected in most of my so-called facts, but Infraworks has been around a bit longer than that. But the content that's inside there, Infraworks has a large library of roads and vehicles and trees and people. They weren't designed knowing that they were going to be taken into something like simulation. So you have to, inside Infraworks, and there's a bit of trial and error, and we could share with you some of the content that we know that works to jumpstart you if you're interested. Choosing the right content is important. Going on to the next stage, you make your life a lot easier. So now we've talked about the modeling the environment inside Infraworks. We've rationalized it. We're drawing towards the end here. You're doing well. We've prepared everything for the Stingray environment, and this would be the point when you could use other platforms, and I was going to talk about Open Driving Simulator, but this is the Stingray Autodesk workflow, and now we have to start populating, and we can take vehicles. Now this is, there's many nuances to driving simulation. We can take the cars from Max, and there's a great, just brilliant. You can take these string lines from Max and use the plug-in Civil View inside Max to populate your city with cars so quickly. It's a great tool. You can say, right, okay, they're all going to run, these are all the center lines of your roads. They're going to have 2 cars on this side of the road, 3 cars on that side of the road. You can sort of set a density, and you will have all these cars moving around your city. And you think, great, job done. Remember what I was talking about earlier with the artificial intelligence, though? These cars are just running on a path, and they just start and stop, and they will ignore you and any of you. They don't avoid any of your interaction. So if you're using Civil View in Max to populate your Stingray environment, you have to switch collision off, and you have to have no artificial intelligence, which then you go, well, okay, it can deploy quicker, but you get the downside is that you got there's little or no artificial intelligence. Something that is great we learned about Stingray is this, it's not switchback, but there's this dual process. Can run both if your machine, and definitely recommend that you look at Autodesk's recommendation for the hardware. They run it on 2 screens. You have Stingray on one screen and then Max on the other screen. And there's a live link between the two. Any changes you make in Max is instantly reflected in Stingray, not vice versa, just that direction. And as you move around your model inside Max, actually the camera, the virtual camera inside Stingray also moves as well. So you can see very quickly, and that's a great tool. Just that it probably wasn't simple from Autodesk's point of view, but it's a great way of adjusting your content in one platform and seeing it updated in the other. Stingray comes with a template that is a way of representing a vehicle inside your model, setting up collisions. It comes with, sets up the environment. So that means when I say environment, I don't mean the physical one. I mean things like the lighting, the exposure of your camera, some volumetric lighting, setting up the physics of the car itself, let's say the friction on the road, the braking, turning circle of the vehicle comes with a pre-loaded vehicle. It also comes with a little basic menu system for you as well, that when you deploy, you get this great menu system. I've just realized I haven't talked about the deployment of Stingray. We're probably, if you're familiar from an engineering and master planning background, you will be familiar with using a platform to visualize your model, your environment. So you'd use maybe Navisworks, you would use Infraworks. So that means that you have to take your laptop to the client's office, to the public consultation, running Infraworks. The output of Stingray is an executable program. It's an exe or it's on the Mac or for your Android device. Actually deployment is an executable file. So that means there's an issue around IP, which is an interesting one. If we get time, I'll briefly mention that. You're actually creating an executable file. So you can package that up and send it off to somebody else. And they don't need to have any special software on their computer. They can just run it. They'll have to do a virus check on it. And we're not talking about 4 megabytes of data. These are usually fairly large files, but there's enough sharing platforms out there that you can deploy to that, which is quite, that's a good way of collaborating with other people. We're nearly at the end now. We've only got, I think, a couple of slides left. So we would use I mentioned the Stingray driving simulator template. So we've got the template there already, and we've got the environment set up. We've rationalized it. We've done some testing on our own PC, and we can see it running on our development platform, but we will need to test it on our deployment platform. So if you do start to dig down into Stingray, there's some great, Autodesk has forums, tutorials on there to help you, certainly helped us, and we're talking with colleagues in the UK and the US who've helped us here as well. One simple bit of advice is just replacing I've mentioned it before about the trees. So Stingray creates instances. If you're from a CAD background, it's a bit like a block basically, to reduce some of the load on the processor. Some other things to consider when you're developing an environment is the draw distance. This is all gaming. If there are anybody from the gaming background, they're probably thinking, what's this guy? We're really starting off in this. So the things to consider are things like draw distance, so how far away will the computer need to render so that you can see it on the screen. Things like lighting, your shadows, when do they get drawn, exposure, your fog, which is a way of obscuring to reduce. The fog reduces what you can see in the background to reduce some of the load on your processor. So this is all the type of workflow which is not typical in the construction industry. There are people like me, we're sort of a handful of us, because we have structural engineers, highway engineers, we have planners, we have project managers, but actually guys who are developing gaming and understanding some of the issues involved with this are actually sort of fairly few and far between at the moment. Last stage, I think this is nearly my penultimate slide. So let's get it out there, let's test it, we'll put it on. As I said, it's an executable file. We've got options for our simulator. We need to get feedback from the people who've tested it, make sure it's running okay, and to get the feedback to the engineers, designers themselves. There's a whole spectrum here, you know, just driving around. But if we can start to add point system, that if there's the interactivity that you can add inside of Stingray or inside of your game is limitless. But we are unfortunately constricted by our budgets. So that means that we would have to make sure that this deployment is suitable for the purpose, and that's where teams like mine come in, and where we work with our own guys and with the client to make sure that the driving simulation is fit for purpose. And I have had comments back about, hey, you know, I'm on the simulation, the visualizations look a little bit simple. And it's like, yes, okay, but that's because we're looking at merging traffic and how to understand the acceleration and deceleration lanes. And if your car looks a little bit blocky, or your buildings don't have a texture on there, you know, is that really the purpose of it? So there's a little bit of management of expectation on the side of it. So my clock here says 5 minutes left. I think that was quite a lot of listening on your part. So thank you for your attention. So questions are on the platform. I think hopefully if you've got the app on your device, I'll be in the reception area if you want to come and grab me. I'll happily bore you to death all about it and talk about the nitty-gritty, give you a card and we can talk about it later. And so although that says questions, the questions will be taken. We've got 5 minutes unless there's any burning questions from anybody. No. Okay, thank you for your attention, and enjoy the rest of Autodesk University. Thanks.
Cheers, Charles. Thank you. Thanks very much indeed. Charles, thank you very much indeed to you, and thank you to all of you for your attention throughout the morning sessions down here. We now treat you to a little bit of food. Please do make sure you fill in your passport details over there whilst you're out in the exhibition area. Lunch is now being served as well. We'll look to get back in here round about 2:30. We'll put a call out there in just a little while. But as Charles mentioned, if you've got any questions for him, got any questions for any of our speakers, this is the opportunity to ask them of they. We'll see you back in here about 2:30.